Welcome to the third assignment for the Fab Academy 2020 cycle. This time we're going to be laser cutting, computer controlled cutting, so that's either laser cutting or vinyl cutting. There are two assignments essentially. One is a group assignment, and since a lot of us are remotely connected, that means we all need to do an individual group assignment essentially, but we'll document it in a one clear page, and I'll explain that in a moment. And then we have the individual assignment, which is to cut something with either the vinyl cutter and then document, design, and cut something parametric, essentially, and I suggest a laser cutter. One key thing is to account for the curve. And the curve is the width of the laser beam that is cut from the material. So you can't just cut a form and then have it press fit together. You have to account for the curve and input that into the design. So adjusting for the curve thickness, counting for the curve, means that you need to measure. So what you can do is you take a design file, you laser cut rectangles up to maybe say 14 pieces. Then you measure the change in difference and divide that by the number of shapes you've made. Here is a simple example. For example, you need to cut this out and then put this all together and measure the difference of the laser beam. And we should do that all together in our all individual labs and document that process as well. When it comes down to parametric design, we did put together a little playlist here for Fusion as an example. And for those who don't know what parametry is, it's basically making variables which you name. You put a name to the variable, and then you express that variable with a length in millimeters or with a formula that you've designed and specified beforehand, and then you make your design based on the names instead of just the lengths. So you should be able to go back, change the variables, and that should ripple through your entire design and change the shape of it. This is a very nice video that goes through how to make a parametric design in Fusion. What this does not account for is the curve. So you need to be very careful and keep that in mind. Also, on this playlist here, I did put together a little playlist. You can use this if you want. You don't have to use this if you find something better. But here's another example on how to flat out structures in Fusion. You can take a press-fit design that you've designed from the ground up, and you can then use Fusion to lay it out flat for you, so you can later on laser cut that design quite easily. Unfortunately, I haven't found a built-in way for Fusion to export SVG files. You can find add-ons or additions for it. You can also download the files as STL and use something like Tinkercad to export the SVG. But the built-in design is DXF. So Fusion has a DXF export function, which is
Can I add?
Yes.
I'm linking a instructable page where you can use machining, so the CNC workspace for exporting laser cut files. So you actually, yeah.
Okay. Can you put that in the document, in the docs?
Yeah, I'll do that. But I just put it there in case anyone wants to click it later.
Yes, I'll put that in the description here. DXF files, there are DXF files that you can work with, but they're a pain in the butt. I don't support them don't like them, but you can work with them. It's possible. In this assignment here, we'll have a group assignment page, and we'll provide you with a template that you can fill in your kerf measurements, where you'll be able to account for your own kerf, and you should document your own laser cutter. And afterwards on Monday, we'll put that together into a single page and put that on our generic Fab Lab Iceland or shared page that we have either over here. But yes, shouldn't have to be too long. Any questions?